Good day guys, being here. Today we're going to use adaptive family to model a, a skeleton of this. It's a railway. I think it's a railway feeder, or I'm not sure about the actual name. But yeah, so the skeleton of this structure. Okay, so let's do it. So first, let's create a generic model, adaptive, and so place one point and make it adaptive, and then place another point, draw a work plan, set work plan. So pick the horizontal work plan and place it on point 1. Then we can drag this point up, and also we can create a parameter. Let's call it H instance. Okay, so now if we select these 2 points, we can make a spline and make it reference line. Okay, so this will be the skeleton of this the vertical the column. Okay, so now let me just go back here, and I'm just going to do a screenshot of this image. Okay, so now we have this one, right? And then we need to create, so we need this one, and also this one. Okay, so let's call this one A, call this one B, and call this one C. Okay, so we're going to create create three parameter instance parameter for these, and of course we have this H already, right? So now let's go back to Revit, and so first place one point, draw on face, and place it on the reference line. So now select this point, so you will see this. So this is currently is so measurement type is normalized curve parameter. So let's change this to segment length. So now this become 6 meter. So I believe it's from this point to this point. Okay, so we just need to flip it. So we change this measurement from beginning to end. So this the segment length become the length from the top point to this point. So now we can, so because this distance is a, so we can create a parameter. Let's create a instance, and OK, and OK. Okay, so now for the B and C, the easiest way is to create 2 circles. Okay, so reference circle, draw a work plan, set work plan. So pick the vertical work plan of this point. So tab again. So this one, and then create a circle with a radius dimension, and then select this radius dimension, create a parameter. Let's call this a B. Okay, so go back here, B. Okay, instance as well, and OK. And then another one, so reference circle, draw a work plan, set work plan, pick the vertical work plan of this one. So tab, yeah, that one. Pick and draw another circle, and reference, oh sorry, dimension, and then pick this dimension and create another. So this one will be C instance. Okay, so now we can just place a point, draw on face, and place it on this reference line. Select this point and use the holes by intersection. Pick this reference line. So now this point. So if we select these 2 points, create a spline, make it reference line, create another spline, and make it reference line. So this will be this. So A, B, and C. Okay, so now if we change, go to family types, if we change, so for example change A, so you will see it will adjust. All these 3 points will will adjust accordingly. Okay, so let's try to change it. This one, yeah, all good, all good. And then maybe this height. Okay, so now let's go back to this image, and from this image we can see this one's a little bit longer, so it extend to roughly here. It looks like this is actually a fixed distance, so this one is a fixed distance, and then this one, so the one on the top move along this this member. Okay, so we can do that. We can extend this one. Okay, so what I'm going to do is place one point, draw on face, and place this point on this reference line, and then we place another point, draw on work plan, set work plan, and pick this reference. So see this work plan, which perpendicular to this reference line. Okay, so pick this one and then place it on the point. So just make sure you pick on the point, and when you see this warning, which means it's correct. Okay, so it's correct. We'll click OK. So now select this point. So see this direction, which means if I drag this way, it will be a positive offset. So what I'm going to do is select this point and I'll just flip it. Okay, so now this point go that way. So now we can just move this point to the end, to this end, and then we know that this distance is this offset. So I'm going to just create another. Let's if we have this as C, and if we have the overall length as D, maybe we can call this one A. Okay, so let's just create this parabola. Let's call it E. So instance, okay, and okay. So now also we need a parabola D as well. D will be the overall length from this point to this point. Okay, and so let's just give D a number. So let's maybe 2.5 meters, and then the E will be, so if we go back here, E equals D minus C. So if we can just here on the formula, we can type in D minus C. So now apply. Okay, so now we have, so now we can select this point and this point and create a spline, make it reference line. So now we have this one. So if you select this reference line will always equal which one, D. Okay, so this is D. Okay, so now we have this one, D, all good, B, and we can control C, we can control A, and then let me just erase this. Okay, so we can see. So in this family, so we also need here, so a horizontal member. So it will be placed onto this frame. Excuse me. So now we just need to place a point. Okay, so draw on face and place it on this point. And so from this image, I guess this one, let's just make it this always horizontal. Okay, so now to make this always horizontal from this point, we need to I think we need to find another point that with the same height, so vertical, so height somehow. So I found a way to do it, but I'm not sure if it's easiest way. So if you find a better solution, please let me know. So now I'm going to show you how to get a another horizontal point to. Okay, so in this one, so because we know this is A, this is B, and this is, so from this point to this point is C. Okay, so in a triangular shape, we can get the angle, any angle, if we know A, B, and C. Okay, so for example, this angle, so let's call it capital B. So B equals arc cosine bracket, I think should be a square plus c square minus b square divided by 2 times a times c. So this is a formula for the angle B. So we can get angle B. So once we get the angle, let me just erase this one so we can draw a triangular shape here. So maybe erase this one as well. So this this is B, okay? So this angle is B, and then in this triangular shape, so because this one will be 90 degrees, okay? So because if this is 90 degree and this is vertical, so this will always, this line will always be horizontal, and then we can just get this point. So if we can, we know this angle B, and also if we know this one, the length of this, so this should be the segment length between the point, this point to the this point. Okay, so let's call it, we have a F, let's call this F. So, and then we also know B, we know F, we can get this, the length of this one. Let's call it A, E, F, G, G. Okay. Okay, so now let's do it. So go back to Revit. So first we need to get this angle B. Okay, so go family types, let's create a B, and let's use angle and instance and OK. So let's type in the formula. It will be a arc cosine. Excuse me, sorry, a little bit cough. Arc cosine. It will be how. Just need to make sure. So need to make sure. So A, C, oh yeah, all correct. So I'll just use that formula. So A square plus C square minus B square and bracket divide. So it looks like I need another bracket here. Divide by bracket 2 times A times C, bracket and a bracket. Yes. So 67.98 degree. And let me just click OK, and I'll just check if it is correct or not. So angular. Oh, hang on. We need to set work plane first. I'll just use this work plane, DI, angular. Yes, that's correct. Okay, so that's good. So let's go back to the family types, and I think we need. Okay, so let's cancel this. We need this. So which is F. Okay, so this one. So we just need to change. So currently it's actually. I just want to double check if this point is placed onto the right reference line or not. I'll just maybe delete this one. I'll place another one to make sure it's correct. So place another point, draw on face, and then move. So you will see this one. It will when you place this point, will highlight this reference line. So which is correct. But sometimes, so if I tab, so see, you will place it onto the longer reference line. Okay. So in this case, hang on. Let me just double check. Let me just have a look in the image. Yeah, I guess in this case, it doesn't matter actually. It doesn't matter because we are using the point from the segment length between this point to this point. So doesn't matter which reference line you use, either this one or the longer one. It's the same. So as long as this point is not going to this part, I think it will be same. If this point, it will stay in this part. Okay, so let's just I'll just place it on this. Okay, so and then select this point, and then so current is 0.6. If I go that way, 0.7, which means it's from this point. Okay, so we just need to change this to end, and also change this measurement type to segment length. So now 563 is the distance between this point and this point. So we just need to create a parameter. So this one will be f. Okay, so let's create a parameter f. Okay, so now we can get, we know this f, we know this b, we can get the j. So let me think. So cosine b equals g divided by f. So so we need g equals cosine b times f. Okay, so cosine, this is the formula for the j. So we just need to create excuse me. So what I'm going to do is because this one will always be vertical, so I'll just place a point, use draw on work plan and set work plan and place it on this point. Okay, so and then place another one. So if I move this up, this offset will be j. Okay, so let's create a parameter j, instance OK and OK. So now if I go to family types, so I just need to type in this formula. So cosine b times f. So g equals cosine bracket b times f. So apply. So now you will see these 2 points will always be at the same height. So for example, if I move this, okay. So now we can just connect these 2 points and make a reference line. Okay, and then so let me just have a look at this. Oh, sorry, this image. Yeah, so we just need to extend. So currently we have this from this vertical reference line to this point. We just need to extend that. So we just place another point, draw a face, place it on this face, and then place another point, draw on work plan, set work plan, pick the vertical work plan of this point and place it on the point, and OK. So select this point. So once again, you can just drag this that way. We just need to flip this point. Okay, so now move this point to the end of this reference line, and the offset of this point will be, so if I go to here, will be the offset will be this. Okay, so let's call it we have fg, let's call it h. So this will be h. Okay, start from this point to here, h. So now select this point, click on this and create a H parameter. Oops, oh sorry, we already have the H for the height. HI, this one will be I. OK and OK. So now if I select this point together with this point, create a spline. Oh hell, I think there are 2 points there. Let me just pick one. Okay, so 1, 2, and spline and reference line. Okay, so now I drag this one. So this will be this horizontal one. So let's go to family types. So so you can change it. So for example, change it to 1 meter. Okay, and let's play with the F. So for example, 600. Yeah, all good. Yeah, I think all good. Okay. So now we have these are all the skeleton of the family. So and then once we have all these reference lines and all the parameters set, so we can then place the actual model. You can use a suite. You can just model those family using the create form, or you can just place nested family into here and then create a very detailed family. But I'm not going to do that because that will take a long time, but just to show you how to model this the skeleton of this family. Okay, so the last part, I think it will be quite easy. You can just place one. So I'll just zoom in a little bit. I'll just do a screenshot of this. So the last part. So now we have this. We have the vertical of the column. We have this one. We also have this one, and then so this one will be just place a point here. Do it a vertical one, and then this one will be it can be a horizontal one. Let's pretend that's just horizontal one. Okay, and then I think that's pretty much it. I'll just quickly do it. So another one will be place here, right? And then of course you can create a parameter. So from here to here, you can. So if you want to use for example, you can use the length from this point to control that point. That's okay. So you can change this to 0.6. We can flip it. Oh no, sorry, not flip. We can change this to end. Yeah, 0.3. So it starts from this point, and then we can change this to segment length. So now we can. So you can just create another one. So A, F, G, H, J. So J, you can use J to control the distance between this point and this point. Okay, so and then you can just place another point, draw a work plan, set work plan, pick the horizontal work plan on this point, and place another point on this point. Oh, sorry. Looks like I picked the wrong one. Let's just do it again. Point, draw our work plan, set work plan, pick the horizontal work plan on this point, and place that on the point again, and click OK. Now if I drop this down, so this one will be another parameter if you like to. So if I K, okay, K, and let's just connect the reference line. So this J, you can control the location of this point, okay, and this K is it's the distance between these 2 points, okay, and then the last one. So the last one will be you can just you don't need to model for the structure. You can just model a horizontal one, and then you can just place and create create a separate family, maybe adaptive family, to place it there. Okay, I'm just going to show you this one. So this one, I think it will be a little, I guess this one will be able to rotate from this point. So it can be rotate, which means the length, so from here to here, it won't change. Okay, so what I'm going to do is, so reference circle, draw work plan, set work plan, pick the vertical work plan of this point, and then do a circle. Okay, so and then create a radius parameter, and then so this will be the length, so from this point to this point. Okay, so let's call it so what do we call it? Hell, what cancel that. I'll just create a new one. Oh, we just need to check what HIJKL. Okay, so let's call it L. Create a L instance. Okay, so now we have this circle, and then we just need to place a point. Okay, so on this circle, so we need to use a play on face and place it here. And okay, so if you select this circle, and so instead of this normalized curve parameter, so we can change that to angle. So it's currently 158. Let me just try to find where the 0 is. Okay, so okay, 0 is here. It's here. 0 is also same 360, but 0 is here. Yeah, I think that's okay. Yeah, maybe just leave it as 160. That's okay. So we can just create a parameter for this angle. Okay, so I'm going to call it how about angle A, capital A. Instance okay and okay. So now if I select this one and this reference point, we can create a spline and reference line. Okay, so now this will be this. Okay, so from here to here, and then you can adjust that angle. So let's do it. So you can try JKL. Okay, let's try 200. Yeah, good. 200. Oh, good. And this one will be the radius. Yeah, will be the length of that. So if let's change that. Oh, good. 600. And then also use that angle to 150 to adjust that this. Okay, I think that's it. So that's it. Yeah, they are all reference lines, but with all these you will be able to create a fully parametric family of this. Okay. Sorry about my voice. Yeah. If you have any question, please let me know. I'll see you next time. Thank you. Bye.